For this video, we are now going to compute the distance between points, but strictly, we are going to use here the formula previously discussed as we connect it in the topics on analytical approaches to modern geometry. The usual formula that we use during junior high school or even senior high school can be used as a verification or checking, okay? But here, let's just practice the formula that we used. Take note that for the first item here, P, distance between P and Q is equal to this one here, the length between Q minus P. So we're going to solve for Q minus P first, get the length using the formula for the length, and whichever will be the result, that's the distance, okay? We have shown the result for this to be the same as the result using the formula in high school, junior high school level in one of the videos in this playlist. You might want to review that on your own time. So here are the points, 1 and 2 for P, 5, -2 for Q, and R is -4 and 0. So for this one, they can start with Q minus P, okay? So we can automatically subtract here, so that's Q, 5, of course 5, -2, minus 1 and 2. So you will have here, sorry for that, you will have here 5 minus 1 and a -2 minus 2. This results to 4 and -4. Then the length of that is just equal to the square root of the squares of the first and the second component, which will give us 16 plus 16. This is square root of 32, which gives us a simplified result of 4 square root of 2. Again, please verify this when using the usual formula during our high school years. Now, we know previously that this is just equal to that. So we can automatically say this is also 4 square root of 2 if you have units, 4 square root of 2 units, right? But if you would like to see really if this is true, of course you could have here this is equal to P minus Q. So you will have P minus Q first, okay? P minus Q is, your P is 1 and 2 minus 5 and -2. Sorry for that, -2. So you will have here 1 minus 5 and then 2 minus -2, or 2 plus 2. So that's actually -4 and +4. Hence, you have here this notation, sorry for that, is equal to the square root of the square of the first term and the square of the second term, which again, 16 plus 16, square root of 32, or 4 square root of 2. So if you know already the property discussed before, you automatically get this answer. I'm just trying to show this here as further proof that they are really the same. Now, moving to our next item, P and R. Take note of our P and R, okay? So this is actually the distance between P and R is equal to the length of R minus P. And R minus P, for our R, that's -4 and 0. And our P is 1 and 2. Am I right? Yes, 1 and 2. So, you will get here -4 minus 1, 0 minus 2. You will have here -5 and -2. Hence, the length of that is equal to the square root of the square of the two components, the sum of the squares of two components. You have here 25 plus 4. This is actually equal to square root of 29. So it's okay until here. Just stick with radical expressions if possible. Okay. Now, you could also check distance of R and P, and again, as mentioned, they must have the same result. Now for R and Q, so this is actually the distance of R and Q, between R and Q, that's Q minus R. So for Q minus R, our Q was 5 and -2. Sorry for that, it should be parentheses. Again, 5 and -2. 5, -2. Our R is here, this one here, -4 and 0. This is 5 minus -4 and negative 2 minus 0. That's actually 5 plus 4, which is 9, and negative 2 here. So the length of that is equal to the square root of the sum of the squares of the components. Negative 2 squared. This is, we know that to be 81, and this is actually 4. So in short, the result here is square root of 85. Let's check if this could still be simplified. Okay, no more. Of course, because if 85 divisible by 5, but it should be 25, right? So it cannot be. So let's stick with this as well as this one here. Only the first two examples can still be simplified and have the same result. So this is how we solve the distance between points, and same as vectors as indicated here, okay, using the formula we discussed in this playlist. Try to verify using the usual formula in our high school years if these results will also be true. Thank you very much for watching.